In this video, I'm going to be showing you how to build out a customer service chatbot. Within this video, we're going to be using the B Agent framework. This is a project that was started by the team over at IBM. And what's unique with this framework is that it's built natively for TypeScript. If you're familiar with the AI agent framework landscape, you'd probably know that a lot of these tools are generally speaking Python based. As a TypeScript developer myself, I was really eager to try out this framework to see how well it would work for various use cases. And honestly, this is probably one of the easiest ways on how you can get started with building AI agents if you're a TypeScript developer. Now, the other thing that I really like about this is that you can use the Llama series of models. You can use the brand new Llama 3.3, which I'm going to be showing you in this video. We're going to be leveraging Grok in this demonstration. We're going to be using the new Llama 3.3 70B speculative decoding model, and this is going to make our agent incredibly fast. So in terms of some of the key features, there are a number of built-in tools that you can leverage. There's a code interpreter within the framework. There's a number of different implementations of memory as well. And you also have the ability for serialization. If you want to have complex workflows, say if you want to pause particular workflows and then resume them at a later time, you'll be able to do that. You also have instrumentation. What's nice with this is you have the full visibility on what the agent is doing. And that's one thing that I really love about this framework, because what it allows you to do is, if I look at the example that I have here, I built out this capability to see all of the details of what is happening before it gets to the final response there. Here we see that it has a thought. The user wants to know the location of the Seattle store. I can use the get store locations function to find this information. Then based on the tool name, we're going to get the argument for that tool. Then we have the tool output, what the location is, and then we have the final thought. I have the location of the Seattle store, and then we have the final example here. The Seattle store is located at the following. The nice thing with this framework is it really is batteries included. You can define the functions on what you want to have the agent do, and then it already has all of the pieces set up for it to think through, reflect. It has all of those mechanisms that you would have otherwise had to set up. It passes the context from the tool. It also has built-in capability to pass the tool output, to have that thought, and all tied in within the context of where you get the final answer. Basically, it does all of the plumbing of connecting the different pieces of the tool input output, all the way to having that be a coherent answer at the end of it. In this video, I'll show you how you can create these conditionally rendered UI components, and also how you'll be able to get answers. Just to show a couple of the demonstrations, if I say, I need help right now, who can I call? There's a function within here, which it will determine if there are urgent requests, go to a phone number. If it's not as urgent, send it to an email. So if I say, how much is shipping beans to Europe? I can send that through, and then within here, we'll see, okay, here's the shipping costs. We also have how long it takes, and you can ask it about various regions as well. Another feature within here is I can say I want to join the coffee club. And if I submit that, it renders this modal, join the coffee club. And what you could have this modal as is it could be something that gets sent to an endpoint for your mailing list. You can have things like the frequency, their roast preference, and all of that. While this does a number of different sort of custom functionality, I promise you that this is much easier than you think that it's going to be. What we're going to be using in this video is I'm going to be using the Grok implementation. The other nice thing with this framework is you can use LLAMA. So if you want to use local models, you will be able to use that as well. For the framework itself, they also have a ton of really great examples in here if you'd like to check those out. Also, if you're looking for some full stack examples by leveraging the B agent framework, they also have this BUI where it has a number of different capabilities that highlight the features that are built within the framework. I'll also put the link to all of this within the description of the video if you're interested in checking any of this out further. Finally, I'm also going to be showing you how you can leverage a hosted Postgres provider if you want to have a lot of the pieces within a managed database. Instead of maybe having all of the pieces that you might tweak, like prices and shipping times and all of that being hard coded within the backend, I'm going to show you how it can be a little bit more manageable by leveraging a simple Postgres setup as well. The other thing to know with this is everything that I'm showing you within this video, you can try completely for free. You'll be able to leverage the free tier on Grok to use this. You can use the free tier on Neon. And then of course, the framework is obviously free as well. What we're going to be doing is I'm going to set up the database really quickly. We're just going to set up the schema database, and then we're going to be setting up the backend of our agent architecture, and then we're going to go through the front end, and I'm going to show you some tricks on how you can set up some of those things like the conditionally rendered UI components and what have you. The first thing that we can do is we can set up a simple project on Neon here. So I'm just going to call this IMB demo. Now, any secret keys that you do see on screen here, don't worry about it. I'm going to be deleting these after the video goes live. The first thing that we're going to do as soon as we set up our database is we're just going to go over to the schema here and we're going to set that up. Once that is set up, if we go over to our tables, we should be able to see all of the different tables here. Once we have that, we'll go back to the editor here. We'll make a new query, and then we'll just seed this table with some information. And I'll go through this in just a moment here. Now that we see that that was executed successfully as well, we can just quickly go through some of the things that we have here. Within here, we have a handful of things that the customer service chatbot can answer. Things like brewing methods. If you ask a question about the AeroPress, like I had asked, it will give you the water temperature as well as the brew time, grind size, and all of that. For the brewing ratios, we also have a handful of other tables within here. So information about the coffee club benefits, being able to see the delivery times as well as the cost for the different regions. We also have our store locations here. We have things like the hours and times and address. You can see their specialties. If a user has a particular question on any of these different things, you can basically see how you can leverage your own proprietary data and tie this into custom tools that you can plug into the IMB agent. Finally, if you do have support questions as well that are specific, you can give a bit more information. There are a handful of other categories within here, but largely these can really be swapped out to anything that you want. These can be external APIs or what have you. They don't have to be about coffee, obviously, or they can really be about any service that you want to leverage. The first thing that we're going to set up is we have a standalone Express server. With this demo, you'll be able to find all of the code within the description of the video. I'll put this within a repo where you can pull down and do whatever you'd like with it. The first thing that we're going to do is we're going to import a handful of things. Now, all of these will become a bit more clear as we go through the examples. We have things from the B agent framework. We're also going to be using Express, Zod. We have things like cores to be able to get the requests in, as well as the pool from our database file. The first thing that we're going to set up is you can remove the .example if you pull this repo down. And within the .env, you just have to get your Grok API key as well as your database file. Just to show you where those are, if we head on over to Grok, you go to API keys, you can generate your key. And just like you saw when I set up the Neon database, to get the Postgres key, you can just go to the dashboard and then you can copy your connection key and paste them in here. So once you have that, just make sure you save out your .env and then we're good to go. From there, we only really have two files that we need to concern ourselves with. We have the db.ts and then we also have the index.ts. Within here, we're just establishing the connection to our Postgres database. And then within the index.ts, this is going to be where we have everything that we've set up within the IMB framework. Within here, the first thing that we're going to do, we're going to import a number of different dependencies. This is going to be an Express server. We're also going to be using Zod. We're going to be using cores to be able to have the React application on a different server and be able to interact with it from the front end. And then we're also going to be connecting to that pool, so that DB file that we had just set up. The first thing we're going to do is we're going to initialize our Express app with some middleware. From there, we're going to go and configure our Grok model. We're going to set the temperature to be really low, so it's a bit more deterministic. And then from here, you can grab your model ID. So like I mentioned in this one, I'm going to be using the LLAMA 3.3 70B speculative decoding model. What we're going to do is we're going to declare a handful of dynamic tools. Dynamic tools are effectively, you can think of them as functions that are mapped with natural language so LLMs understand how to use them. Within our first dynamic tool, this is going to be a tool to get the brewing information. As you saw in the example that I showed at the beginning of the video, I asked about specific brewing instructions. What this function will be asking as an input schema is going to be, okay, is the user asking for an espresso, pour over, a cold brew? Like what type of coffee and the question are they asking about? Also, what type of strength are they asking for? Light, medium, or strong? And then if you ask for the number of servings, for instance, if you say, I have an AeroPress and I want to make servings for 4 people, it will be able to handle a request like that as well. Basically, to implement this, what we're going to be doing is we're going to be making an SQL query based on the different brewing methods that I had shown within our Neon database. Within here, we're going to be making our Postgres request. We're going to be getting the brewing method as well as the brewing ratios. The thing to know with this is you can really use anything. It doesn't have to be Postgres. These can be external APIs that you tie into or using other data sources as well. Now, we're also going to be calculating the measurement. So depending on what the payload that the LLM extracts from the query, like if we say, okay, there's going to be 4 cups that we want, it's going to go ahead and make that calculation based on the output of how many servings that the LLM detected. If you say I'm brewing for 4 people or 2 people, or I want a liter of coffee or what have you, it's going to go ahead and take that serving ratio, perform the calculation to show you how many coffee grams that you need, as well as how many milliliters. Obviously, this is just an example. It can really be anything within here. These are all just for demonstration's sake. Finally, within the tool, we're going to be returning this as a string. When it has that final reflection of the response from the tool, we're going to see that the recipe is for this many servings. So we're going to see the grind size, the water, coffee recipe, temperature, brew time, and basically everything. And all of this ultimately gets rendered as those conditionally rendered UI components on the screen there. Like you saw on the outset of the video, it showed a nice little modal with all of the different information for the coffee. Within our next tool, we're going to be setting up one to get a shipping estimate. The description is provide shipping estimates as well as delivery information for different regions. It's only ever going to be these different regions. It's going to be USA West, USA Central, Europe, Asia, South America, other. That's one thing that I really like about Zod in combination with function calling is it allows you to write this really succinct block of code where you can specify, okay, I have an enum of these particular things. If you're going to be putting in a region, it's going to absolutely be one of those things. When using things like enums can often be a good tactic for preventing hallucinations as well. Then if there is some urgency that's detected with the shipping request, we can specify, okay, this might need to be express shipping or what have you. This is an optional parameter. We don't need the user to specify the shipping method that they want, for instance, because typically speaking, they probably wouldn't, but there could be some edge cases where that could be the case. To indicate that, you can just specify that it is optional with that method at the end there. Next, similar to the previous example, we're going to be getting the shipping regions from our Postgres database. And then what we're going to be doing next is we're going to be processing these shipping details. Depending on what the input was, if we did have an input method that specified whether it's express or standard or what have you, that's going to inform the context that we're ultimately going to return to the LLM just like this. Within here, we're going to say, okay, the shipping time to this region has the delivery time of this with the shipping cost of that, and go through all of the other information. So it has the context that it can feed back to our AI agent and ask about particular shipping queries. Next, we're going to be defining our modal that renders on the screen for if the user wants to sign up for the Coffee Club program. They can put in their name, email, as well as the frequency, as well as their preferred blend and what have you. So similar to our other tool calls, we're going to be making a query to our Neon Postgres database to get the information specifically about the Coffee Club benefits. With this setup, you can go and change whatever you have within your database and have that information that gets pulled into the agent. Again, within the handler here, you could reach for an external service. You could even hard code things if you wanted. I find for the most part, it is nice to have some of those pieces, especially pieces that might change and grow over time, like benefits for a coffee club or shipping rates or what have you. It's nice to probably have those separated within a database somewhere, because then you can just go over to Neon or build a simple little admin UI and be able to update those different pieces of your customer service chatbot. Next, we're going to be defining a tool. And what this tool does is we're going to handle these support inquiries with some routing. If a user has an urgent request, we're going to determine whether it's a low priority, medium priority, or a high priority request. If they're saying, I need to talk to someone right away, it will detect that that's a high priority request. And then we also have the topic as well as the categories for the inquiries. If it's a product, shipping, technical, or a wholesale related query. Finally, we have the optional information for the customer name and the order number. Now, one thing to note with how I set this up is I made the intention of not needing pieces that require unique customer service information. Now, with that being said, what you could do is if you do have an authenticated app, is you very well could pass in the customer's information and have it query specific things related to their account. Let's say you have an authenticated user and an ID that's associated with the user. You could use that within your query for Postgres to get the information about products that a user might have ordered, for instance, or maybe more order related queries that are unique to that particular user. In this case, I wanted to keep it relatively broad, but If you added authentication and you authenticated on the route for where the agent architecture is, you could very well have an agent that is able to ask questions specific to whatever that user has within their account, for instance. We're going to be setting up a tool where we have these different levels of urgency, so low, medium, and high. So this is going to largely be what this tool does. And within here, if the query is an urgent request, like let's say someone's typing in all caps and they're very animated in what they're asking for, we might send them to this support number. Alternatively, if it's a low level urgency, we could send them to a self-serve portal or something like an FAQ page. And then if it falls within the middle, we could say, okay, please email at this email and we'll respond in this particular timeline. Finally, if there are any errors from this response, we can send back a blanket statement to say, okay, there's some technical difficulties. If you have an urgent query, you can call this particular number. Finally, for our tool call, we're going to have a get store locator. This is one where you could do quite a bit in terms of conditional UIs. In the past, for things like this, I have set up where you could get potentially the coordinates of a store. And then based on those coordinates, you could send them into something like a map component. You could also do things like even reference the coordinates within a Google Map URL and just route them out to Google Maps, for instance. But in this one, what we're going to do is we're going to provide information about the specific stores. In terms of where the stores are located, we only have a handful. We have San Francisco, Portland, Seattle, Chicago, and New York. Once we have that, again, we're going to reach to our Postgres table for our store locations where all the information is going to be held. And then if there is no store at that location, we can just say, okay, we don't have a store. Please check back. We're expanding. Then finally, if we get those results back based on the particular coffee shop, we can send back to the LLM and the agent all of those particular details. Here's the location, the hours, the address, the specialty, as well as things like parking. Now, this can really be whatever you'd like. You can swap this out to other fields, additional fields, or what have you. From there, to initialize a new agent, all that we have to do is declare the variable of agent, and then we can reference a new B agent. And within here, we can specify the LLM. In this case, we specified Grok. So we can specify that we do want to have memory. And then finally, we can specify the different tools. In this case, these are all of the tools that I just showed you. And this is as simple as it gets. If you want to define some other tools that they have built in, like DuckDuckGo or weather tools or what have you, or the code interpreter, you can just add these in the tools array just like that. That's as simple as it gets in terms of using the B agent framework. In terms of setting up an agent, this is probably just about as easy as it gets in terms of setting up your own custom agent architecture without really needing to know too much about how to handle the thinking process, assessing, retrying all of the different pieces that the B agent framework has figured out. Next, we're going to be setting up a handler for our endpoints. Within this, we're going to destructure the question. That's going to be whatever the user puts within the chatbot. Next, we're going to keep track of an array of the different steps that we ultimately send to the front end, and that's going to be what we have within the details here. These are effectively what I'm calling steps. So we have our thought, our tool name, the tool input, the tool output, the final answer, and what have you. The other cool thing that I want to point out is it handles complicated queries with ease. Within this, if you ask, where is the NYC location? Can you tell me how to use it for 2 people? I want to join the coffee club. What it will do here is it will go through and it will specify all of the different tools that it needs to know. And then finally, it will give you that final answer there. The NYC location is this, to use the AeroPress for 2 people. It is really robust, right? All that we really needed to do is define those tools, define our agent, and it does all of the hard work behind the scenes within the framework. All those different steps that we have hidden by default, they're going to live within here. Then finally, to actually invoke the agent, we call this run method. We can send in our prompt and we can specify what the agent does. We're going to say you're a coffee expert, a customer service representative. If the customer asks X, you do not have the ability for orders, but you can answer general questions about the company as well as coffee. In terms of some of the more advanced settings, you can also set the max retries per step, the total max retries for the loop of when you send in a message, as well as the max iterations of the different steps that the agent takes. Now, the other really nice thing with the agent is you can call this observe method. What it will do is depending on the event, you can emit those different steps. There are a number of different steps that it will take. If it's an error, you can push that onto the state of that array that we have there. Or if it's retry, we can push that as well. Finally, if it's an update, we can push those to that array that we have there. Just to circle back here, essentially all that this is that's mapping out to the UI, it's going to be all of those actions that are within those steps, whether it's thinking, performing a tool call, or what have you. In this case, we're showing it within the UI. Next, what we're going to do is we're going to return the response. The payload that we get back to the front end, we're going to have the answer, and then we're also going to have the steps. So that's going to be that array of all of those different options that we had, like I had just shown you. And then finally, within our application, if we have any errors, we're going to log out all of those errors. And then we just have to finally initialize our endpoint itself. In this case, I set up the endpoint to be at the route of ask, and then we're going to be passing in that handler for all those requests. After that, all that we have to do is we just have to initialize our Express server. In this case, I set it up to 3008. You can swap this out to whatever you'd like. Great. So for the UI portion, I'm not going to be going over the page itself. This is all just a placeholder page that I spun up for this demonstration. But instead, what we're going to have here is this chat component, this customer service chatbot, like we've seen on some other websites. Essentially, everything that I'm going to be going through here and everything that you saw that I demonstrated, from the details to the components to the queries themselves, all of that is going to be within this file. I'm going to be focused on this chat widget TSX here. If you pull down the repo, that's going to be the lion's share of where we map the requests to our agent architecture and where we ultimately consume and render, whether it's the messages or those conditionally rendered UI components or what have you. Those are all going to be within this file. Now you can break this out, but for simplicity's sake for the demo, I just wanted to show them within here. The first thing that we're going to do is we're going to import a handful of dependencies. A lot of these are going to become a lot more clear as we go through. Within this application, I'm first going to show you some of the conditionally rendered UI components. Within here, the way that this is set up is if it detects that a tool call has been invoked that's related to the brewing guidelines, for instance, if it's a query about asking how to use an AeroPress or a pour over coffee machine, what that will do is it's going to take the information and extract that from the response back that we get back from the agent. And we're going to make this nice little component based on all of the information that we got back. So depending on what we have returned from that dynamic tool that we declared within the agent framework, that's going to ultimately map to this UI component here. We have things like the serving, the strength, as well as the number of grams within the coffee, water, all of those different pieces like we saw when we asked about the specific piece there. Effectively, it will render this nice little component out and it will give you different instructions based on whether you ask things like, how do I use my pour over coffee machine or my espresso machine or what have you. But that's going to be how it renders that. So next we have our shipping estimate displayed. And again, just to tie this all together, that's going to be this component here. So depending on what the user asks, if they ask for like, I live in America in Los Angeles or something, it will show you the specific one related to that region. So you don't need to necessarily specify what is shipping to Europe. You could specify a country, and the tool call will be smart enough to leverage the enums that we declared to know which one to use. That's where it can be sort of handy. Another thing to note while I'm here is if you wanted to take this a step further, what you could try is to actually add these different products to a cart, for instance, from this chat component. You can imagine if a user types in, I want to order the Brooklyn dark roast, for instance, and you can have that action actually take place and put that within their cart. That's a bit of an aside on how you can potentially build on this if you're interested. Next, we have our store locator component, which is what this looks like here. Now, you could also have like a link here if you wanted to get the coordinates and reference it out to something like Google Maps, for instance. But this is how you can leverage that. And again, if we take a look at how it was determined, we have the tool input that was Seattle. And based on that, we made that request to Postgres. We got that information about our Seattle location. And that's what we ultimately get in order to render this UI component. Next, here's an example of a further component that you could set up. What you could do on the back end is, let's say you want a conditionally rendered UI component for coffee information on if they ask really specific questions about, say, the coffee, you could render something like this. This component I left in as a bit of a challenge where if you want to set up from the backend the tool call to make this work and have the coffee info displayed, you should be able to do that by just adding a new tool call. That's a bit of a challenge. You can give this a shot if you want to try and have this particular component rendered. Next, we have our main display component. So within here, we're going to loop through and determine based on the payload that we get back from the endpoint, what are the tool names that we have as well as the tool outputs. This is effectively how we're going to set up the different state within the application to determine what to actually show within our chat history. Next, we're going to be parsing the response. Within here, this is going to be how we determine what gets mapped to those UI components, if it's the brewing guide, or if it's the shipping rates, we're going to go ahead and take that payload and that key and effectively just render it in conditionally rendered UI components. We're just going to split up the response that we got back from the LLM, and that's going to be how we map to the data that we ultimately show within the chatbot. There's a number of different ways that you could potentially do this. We're going to be breaking out the different lines that we have from that response within the tool call. You could also look at potentially including structured outputs as well. If you want to ask the LLM to have a more deterministic output like JSON or structured outputs is something that's becoming a bit more popular from structured outputs, that is a potential next step that you could leverage as well. But effectively what is going to happen here is based on the tool name, we're going to parse the data and then we're going to give things like the region name, delivery time, the cost, and all of those different functions. That's going to be what ultimately gets mapped into that visual component there. And then finally, we have our typical message. So if a user is just going back and forth and there isn't a UI component that needs to be rendered, that's going to be where we render the message here. Next, we're going to be setting up a simple interface for our message. It's going to be relatively straightforward. Then here, what we're going to set up is that modal for that coffee club input. Now, what you can do here is you can have this UI component submit to an endpoint that might sign them up to an email list, right? Right now, this handle submit just console logs, but what you could do is have this actually log the results of what the user is setting to go to a form for your email signup list. Here, we just have some form features, the roast preference, as well as the frequency and what have you. That's basically this whole component here. Another thing is if you're interested in building on top of this, I would just recommend breaking out those UI components into their own file. That will make it a lot easier to manage. I did set up everything within as few files as I could just for demonstration's sake within the video. This is going to be where we declare a number of things, like whether the chat modal is open, whether it's expanded, what the messages are, as well as the initial message. We have a handful of other things that's going to become a little bit more clear as we go through the rest of this. We're going to be setting up a helper function to extract the store details. Next, what we're going to do is we're going to specify the user message. That's going to be how we track the state on the front end. This is going to keep the order of whether it's an AI assistant message, a user message, and then here is going to be how we query our Express server. In this example, I have it set to our localhost 3008 at that AS route, but this could very well be an external endpoint. You could have it on the same server depending on how you set up and deploy your React application in combination with your Express server. But that's just one thing to be mindful when you set all of this up. The other thing to know with this is I set up the payload to come back immediately with everything. You could also set up streaming, but given that I am using an inference provider like Grok, which has that really fast inference, I'm going to just be sending the whole payload because it happens honestly within just a second or two for all of the different responses and even the different steps. Next, we're going to be setting up how to trigger our coffee modals. And then finally, we're going to set the messages as they come in. We're going to determine that it's a bot message, and then we're going to have both the content as well as the steps that we have set in our state here. Next, we're going to have this function to determine our step styles. All this is doing is we're adding Tailwind classes dependent on the different steps. If we go back to the UI here, we have all of these different colors here dependent on the steps. That's going to just show within the UI based on this switch case statement here. Next, we have the toggle steps function. This is going to be where we hide and show the details. And then from there, we just have a simple handler to actually send that coffee club submission. So if a user fills out that form, we can send that submission just like that. From there, we're going to render whether the chat button is open or closed. Next, we have the widget size here. We can expand it or close it just like that. From there, we can render our main widget. This is going to be all of the different JSX, which effectively makes this component here. Within here, we have the top of our component there, sort of like the header of the chat interface. The main portion within this is we have our messages area. And then from there, we're just going to map out all of the different messages, whether they're from the AI or the user. And then from there, since we are showing these steps within the chat conversation, we can just render them out like this. Now, this is optional. You don't need to show the steps. I do personally like it to see what the agent architecture is thinking, the different tools. It will definitely help with being able to set up your agent and also debug it. But I think, frankly, it is a nice feature just to share with users in general, where users can just see how those answers were ultimately gotten to, what tools were used, and what have you. You could swap out some language potentially to make it a little bit more user-friendly. But this is really just to give you an idea on how you can leverage those different pieces on whether you want to render the thinking piece or the output. You don't necessarily need to render them all. It might just be interesting to render the thought as well as the message, potentially. That's something that O1 does that I think could be an interesting UI. You could add in a similar functionality into something like this. And then finally, within this, we have the expanded step state. It will show all of those colorful steps within here. And then this is going to be where we have those conditionally rendered UI components. From there, we're going to be setting up our input state. And then finally, we're also going to show where all the messages are added. The input, the button, that's going to be what ultimately gets entered and sent to the user. We also have where we can map through and detect on if there are steps that do have tool names to render those components as well. And then finally, within here, you can determine based on the state of if a tool call detects that something like a modal needs to render or one of those other conditionally rendered UI components, you can set that up just like this. Otherwise, that's pretty much it for this video. If you found this video useful, please like, comment, share, and subscribe. Otherwise, until the next one.